Sixth grade lesson 4.5 is using equivalent ratios, and equivalent ratios are similar to equivalent fractions. So that same skill that you've had from the past can just kind of reawaken, and you'll find that you use those same skills. So hopefully you'll feel comfortable with this as we go. And remember, a ratio is a comparison of two values. So let's get into this and have a look at what skills we're needing for this. Okay, so this first unlock the problem gives us a word problem, and no longer are the days where we go, oh no, I can't do it, because we now have the steps that we take over and over and over again to break this into pieces so that we can solve it. We will read the question. In warm weather, the Anderson family likes to spend time on the family's boat. The boat uses 2 gallons of gas to travel 12 miles on the lake. How much gas would the boat use to travel 48 miles? Let's go underline the question that they asked. Here's the question they asked. How much gas would the boat use to travel 48 miles? They want us to find the amount of gas for 48 miles. Then we will go circle the information they gave us. Well, we know it uses 2 gallons of gas to go 12 miles. And that's all the information we need, I suppose, because other than that, we just need to know the 48 miles that it wants to go. So let's draw a picture. I have gas. This is a gas tank. Pretend that's a gas tank. And it takes 2 gallons for me to go, for my boat or his boat to go 12 miles. Let me move this. There we go. For the boat to go 12 miles, this is my key ratio. It's not a unit rate, but it's the ratio of how many gallons take me 12 miles. So one way I could use the table like we did before and push all the way until we get to 48 miles, because the distance is 12 miles. We could use that skill and continue going. That would be one way we could solve this. So if I went 2 miles, double it. They doubled this. We'll double that. 2 times 2 is 4, and 12 times 2 is 24. Or we could do the original amount, 2 times 3, to get 6. And 3 times 12 gives us 36. And then we could take the original 2 and do it times 4, which will give us 8. And 4 times 12 will give us 48. This gives us the ratio for 48 miles. So they will need 8 gallons of gas. The ratio 2 12s and 8 48s are equivalent. So 2 12s is equal to 8 48s. And so the boat will use 8 gallons of gas to travel 48 miles. So we could use the same skill to find out further information in situations like that. Probably good to know if you're going out on the lake with gas in your boat, so you don't run out in the middle of the lake. Hopefully you have an oar to get back. So now earlier I had mentioned you could be using some of the same skills you used for equivalent fractions for this same concept. So this will show us what I meant by that. So let's say I have 3/4 is equivalent to how many 20ths? Well, we can use common denominators like we did when we were adding fractions to write equivalent ratios. So what I would look at here is I have a denominator of 4 and I have a denominator of 20. Well, I could make 4 become a 20 by multiplying it by 5, right? And as long as I multiply his best friend, the numerator, by the same number to keep it equivalent, then I will keep this fraction equivalent, or this ratio equivalent. So I'm going to do 4 times 5 to get a denominator of 20, common denominator, and do the same to his best friend, the numerator. That's going to give me 20 here, and then 3 times 5 is 15. So 3/4 is the equivalent of 15 20ths. So over here where they asked to use common denominators to write equivalent ratios, 20 is a multiple of 4, so 20 is a common denominator. multiply the numerator and denominator by 5 to write the ratio using common denominator. That's what we did here. And then the ratios are the same, so they are equivalent. Okay, we can check our answer by using the table like we did earlier. This is counting 3, 6. Then we're doing times, we're going to just count by 3s, 3, 6, 9, 12, like that. And then we'll count by 4s, 4, 8, 12, 16, 20. And remember, we were trying to find the equivalent with a denominator of 20, and there it is. So that's what we ended up with. The way I like to do it, I'll introduce this to you. I'm sure the book will begin introducing this to you at some point. But if it's not super obvious this way, then one of the tools I use is, I know that 1/2 is the same as 2/4, right? I'll show you in picture. 1 out of 2 pieces is equivalent to 2 out of 4 pieces, right? And the equal sign is saying so. And what we learn as time goes on about equivalent fractions is that if they're equivalent, then the crosses multiplied together will equal each other. 2 times 2 is 4. And 4 times 1 is 4. And 4 equals 4. So if I know that any equivalent fraction, when you multiply their crosses through, that they will equal each other, I can use that to my advantage. I can do 3 times 20 has to equal 4 times x, 4x. 3 times 20 is 60. And my only problem is I have my variable x hanging out with 4. It's being multiplied. 4x is the same as 4 times x. But I can undo that. I can do the opposite, or the inverse operation of 4 times x. So instead of multiply by 4 for this variable, I'm going to undo it, do the opposite, the inverse, and divide by 4. And I'm allowed to do that on the equation as long as I do the same to the other side of the equation. 4 divided by 4 is 1, so now I have 1x left. He's now isolated. And 60 divided by 4 is 15. So that is another way that you will learn in future. For those of you who saw that and it clicked and it made sense, or it sort of made sense, you're welcome to start using that if you want. If that didn't make sense, ignore it for now and keep using these tools that are making sense. Okay, here's another example. I have a ratio of 56 to 42, and I want to know if I bring that 56 down to an 8, I'm cutting something down, what would this portion of this ratio be? One way I can look at this is, what calculation can I do to turn a 56 into an 8? Well, it's getting smaller, so probably it will have to be division. I can divide by 7 because 56 divided by 7 is 8. As long as I do the same to his best friend, the denominator, I have to do the same to both to keep them equivalent. 42 divided by 7 is 6. So 50, oh, that's what they wanted here. I got ahead of myself, sorry, book people, sorry. So 8/6 is equivalent to 8/6. We divide 56 by 7 to get 8. Divide the denominator by 7 as well. And the ratios are now the same. So the ratios are equal to each other. The unknown value is 6. 56, ratio of 56 to 42 is equivalent or equal to the ratio of 8 to 6. We can check our answers by using the table. We're counting by 8s here. This is 8 times 1. This is 8 times 2. This is 8 times 3, which is 24. 8 times 4, Miss Sanchez. Hello. 4 is 32. 8 times 5 is 40. 8 times 6 is 48. And 8 times 7 is 56. And then down here, where 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, 6 times 5, 30, 6 times 6, 36, and 6 times 7 is 42. So we reach that ratio, and that's a matching ratio. These are all equivalent ratios, actually, the whole way through, as you learned before. For those of you who felt like, hey, can you show me that one way you showed me in the last one again? I just want to see. Here it is. If it confused you, then just fast forward right past this part. But if I'm given 3 out of the 4 pieces of information on that ratio, the equivalent ratios, and it says they are in fact equal, I can multiply the crosses to find out what this is. So let's do 8 times 42 is going to equal 56 times x. We'll just write that for now as 56x. 56 times x is the same as 56x. You'll get more comfortable with that soon. I'll calculate what 42 times 8 is. And it is 336. Now 56 is being multiplied by x. I want to isolate this variable and get him alone. That's always my goal. He's being multiplied by 56, so I will do the opposite of that, the inverse of that. Opposite of multiply by 56 is divide by 56. I'm only allowed to do that because I promised to do that to both sides of the equation. 56 divided by 56 is 1, so that leaves me with just that one x there. And now I just need to divide 336 divided by 56. And I will get 6. So x equals 6. So it gave me the same bit of information there as well. The unknown amount is 6, so I get an 8:6 ratio. So again, if that makes sense to you, good. If not, don't worry. That's something coming your way later, but some people like to see that ahead of time, so I figured I'd show them that. So you can continue using, look at what things like reducing fractions or finding equivalent fractions that are higher in number. As long as you do the same to the numerator as you do to the denominator, you keep it equivalent. And you can continue using the table for this lesson too to help you with it as well. So if you have any questions, let me know.